My name is Seth Markle. I'm a senior principal engineer in S3. I've been in S3 for 13 years. I started out in S3 on the indexing team. This is the team that is responsible for managing storage of object metadata. Since then, I've worked on the storage subsystem, as well as our front end and really all across our data plane. In addition to my work in S3, I also sit on the board of directors for the Rust Foundation. Rust, the programming language, is a super important strategic investment for Amazon, and so I'm happy to be able to help out there. So today you've heard some talks, and you're going to continue to hear some talks on fundamentals. Fundamentals are those properties of a system that are generally unseen, except with good fundamentals, the service just works. Today's talks are going to cover a broad range of topics: durability, security, availability, and performance. Delivering on these takes time, effort, and experience to get right. We focus on these fundamentals so you as the customer can focus on innovation. At the end of the day, it's been S3's focus on these fundamentals over 17 years that's earned the trust of millions of customers from all sizes and all industries. So our goal today is to give you insight to architect your applications on S3 and to share our experience with you to incorporate into your own operations and application design. So today we're going to be covering durability and a little bit about our availability. We're going to be covering several topics today. So first we're going to start with talking about our durability culture. Our durability culture, specifically around a durability review process, is how we examine changes to our system before they go live. Then we're going to do a brief case study to illustrate how durability reviews actually look. Then we're going to talk about how we achieve 11 nines of durability using our S3 one-zone and frequent access storage class as the example there. And finally, we'll talk about how our standard storage classes are designed to withstand the loss of an availability zone. This is a lot to cover in 20 minutes, and so let's get started. So, unsurprisingly, S3 has numerous technical safeguards to protect data. Before we talk about any of the technical safeguards, though, we have to start by talking about teams and processes. A core tenet in S3 is that we have zero compromise on durability. The bar we hold ourselves to is to never lose a single byte. And this sounds like a nice slogan, but we need actual processes in place to enforce this. The most important one is the durability review. This is borrowed from the security field with threat modeling. Teams authoring a change to the system start out by writing a threat model, which is an actual written document about the potential threats and mitigations they're going to put in place related to that change. And this document gets reviewed with what we call bar raisers. Bar raisers are high judgment individuals in the team who have experience thinking about durability. Now, bar raisers are just people, right? We're not human compilers. There's no magic there. So we can't take a brain dump from a team that's proposing a change and then come up with all of the problems. And so a more accurate way to look at bar raisers is like a coach. They teach you about how to think about your own system. And that often happens through a series of short brainstorming sessions in preparation for the final review. Having to present a doc is a great forcing function for thinking about your system deeply. More often than not, the author realizes a new threat about their system just by having to write it down for the reviewers. And they build better instincts about durability going forward, especially in ways that help them be able to coach their own peers, and so they often become bar raisers themselves. And so a right way to think about a durability review is more like a teaching and learning experience. And it's great for the presenter. It's also great for the bar raiser themselves and the team members that kind of experience this along the way. So let's look at a sample threat that we might see in a durability review. And we're going to see this written out. The reason we write it out is because writing solidifies your thinking. My all-time favorite quote is by a cartoonist named Dick Ginden. And the quote is, "Writing is nature's way of letting you know how sloppy your thinking is." So in this case, we write out a risk. The risk here is, for this sample system, is accidental data deletion. We never want accidental deletion of data in Amazon S3 buckets, especially due to bulk deletion operations. So here we have a title, and we have prose describing the risk itself, but threats need mitigations. So what are the mitigations in this case? Well, let's talk about some of the mitigations to this particular risk that you can use as a customer of S3. So S3 offers several features for customers to protect their data. The first is S3 versioning. Versioning is a feature, when enabled, that preserves your object history even though you might delete or overwrite the object. And you can restore the object from any old version that you want. And by default, GET request will access the most recent version, including if the most recent thing that happened to your object was a delete, then your GET would return a 404. The next feature that's worth talking about is S3 replication. So S3 replication is a feature where S3 will asynchronously replicate your data for you in between buckets. Those buckets could be cross-account, and they could even be across regions. Usually, S3 can replicate these objects in seconds to minutes, but customers with stricter time requirements can use a feature we call replication time control, which is designed to copy 99.99% of objects within 15 minutes and is backed by a service level agreement. The next feature I'd like to talk about is object lock. Object lock is a feature that follows the classic worm pattern, WORM, write once, read many. With this feature enabled, you cannot overwrite or delete your objects. This is great for customers who have regulatory requirements or those who need an extra layer of protection. Finally, I'd like to talk about backups. While this isn't a direct feature of S3, there are a number of applications, both from AWS and our partners, that offer backups. And backup applications really serve two purposes. One is to maintain a catalog of backups for you to look at. And the other is a restore engine that can take those backups and actually recover your data. Restore is the most important feature of backups, where it's almost like you want to say the feature is restore and backup is an implementation detail, as opposed to the other way around. Okay, so with that background, let's talk about S3's 11 nines of durability. So we take this number very seriously, and let's talk through our approach. So there's three techniques that together help us achieve our 11 nines design goal. The first is end-to-end integrity checking. This is how we make sure that we store what you actually gave us. Next is we store data on redundant devices. We're going to go into that in a bit. And finally, we have aggressive background checks that look for issues with the data at rest. Okay, so let's start talking about checksumming first. So this is you, the customer, and you send us data. Now, our data plane that receives your put request is going to send the data through a series of services. And data might get copied during that process. You know, it comes off of a TCP buffer into an application buffer. It goes back into the kernel and through the network to another application. Along the path, we calculate checksums as we go. This makes sure that services that receive data are receiving the data that was actually sent. At the end of this series of calls, ultimately we have to store your data on storage devices. And for that, we use erasure coding. So erasure coding is a function across data where we can take your data, divide it up into chunks that we call shards, create some extra chunks, extra shards that have extra information associated with them, and then store them across multiple storage devices. Each shard, we want to make sure itself has integrity, and so we assign checksums to each of the individual shards so the storage devices can validate that the shards are correct. But how do we make sure that when we created these shards that we actually did that correctly? Well, this is a process that we call bracketing. With bracketing, we reverse the entire set of transformations that we did to make sure that we can reconstruct the data from the individual shards. And then once we do that, we know we're storing the data that you gave us with the correct checksums. And all of this happens before we respond to you with a 200 success. So by the time you get a 200 back, you know that your checksums have been validated along the way and that we've reversed the whole transform to make sure that the data is reconstructible. And if this sounds like a lot of checksumming, it actually is. So S3 calculates about 4 billion checksums per second across the entire service. It's a huge number. Okay, so after we erasure code the data, we actually have to store it across multiple redundant devices. And so in this particular example, we have 5 devices, just an example number here. And we have a value A that's written across 3 of them, B, C, D, and E. Now, devices are physical real-world devices, and they can fail sometime. And so let's say this particular device fails here, this first device. We have background processes that are constantly looking at device health across the system so that when a device fails, we can find a suitable replacement device and re-replicate the data so that your data is always replicated on the full set of devices. So let's look at how we do this at scale. This is a depiction of us doing it across the whole fleet. You'll notice we always have spare capacity on hand, but it's not like we have a fleet of empty storage devices just waiting for another device to fail. We maintain space on our existing storage devices so that they can all participate when another device in the system fails. And the reason we do this is because we get way better recovery throughput by having multiple devices participate in the recovery than if we just had to do a one-to-one replacement. So this helps us with our recovery throughput. Okay, so now we're talking about the final technique. So devices don't just fail versus being good. Sometimes you'll see bit flips on disk. This is typically referred to as like a bit error rate, where the device itself is okay, but maybe something's wrong with a particular sector on the device. If that were to happen, the data that's stored on that area of the device would no longer be readable, or at least when you would read it, you would read some corrupt data there. And so we are periodically scanning, or continuously scanning, our disks to validate that the data that resides on disk is still good. And this is where we use the checksums that came in during that the first description that I gave you when we create the shards in the first place. And so this kind of ties it all together, where our checksums allow us to constantly audit our data at rest. And when we find an issue, if we were to find an issue, we can enlist our re-replication systems that I described in the previous slide to be able to fix that data so that the data maintains full replication. So let's piece all of this together. So we have replicated data across storage devices, and those devices fail at a particular rate. And we replicate data at a particular rate. And so given those properties, there's well-defined mathematical models that allow us to use these inputs to come up with a durability rate. And so that is where our 11 nines of durability comes from. It is a function of our replication factor, the device failure rate, and our re-replication speeds. Now I want to change gears for a moment and talk about availability zones. So unlike other cloud infrastructure providers, each of our regions has multiple availability zones, and each availability zone has one or more physically separated data centers. Availability zones are isolated from each other on separate fault lines, separate floodplains, separate networking, separate electrical grids to substantially reduce the chance of simultaneous failure. Now you'll notice our calculations of 11 nines of durability do not include zone failure. And the reason is because facility failure is just really, really rare. It's a low probability event. We're talking about things like natural disasters and unforeseen major events. All of S3's storage classes are 11 nines durable. Today, our default storage class and all of our storage classes except for one are automatically protected from data loss due to zone failure. And to illustrate how this works, let's first look at that one storage class that's bound to a single zone, but is still 11 nines durable. So our S3 one zone and frequent access storage class is for data that is accessed less frequently, but requires rapid access when needed. Unlike other S3 storage classes, which store data in a minimum of 3 availability zones, S3 one zone IA stores data in a single availability zone, but it costs 20% less than our standard IA storage class. As mentioned, despite being in a single availability zone, S3 one zone and frequent access is still 11 nines durable. But as I said, it's in a single zone, and therefore it's susceptible to those previously mentioned unforeseen natural disasters. So how do you prepare for that? Well, like we discussed earlier, you start with the threat model. So thinking about zone failure in the context of threat modeling exercise like we did before, we have this statement. We must protect data we store against the unexpected loss of an entire zone. We assume that any single facility may fail at any time, and that we must still protect the durability of data that is stored within it. So customers who use S3 one zone and frequent access are willing to design their applications around the risks in exchange for lower storage prices. So what mitigations do customers take for this? Well, the mitigations we recommend for using S3 one zone and frequent access are to store only recreatable data or have a backup solution. So the storage class is for customers who understand and can mitigate these risks. Like I said before, the rest of our storage classes, including our default storage class, have both 11 nines of durability and can withstand facility failure by default. So here's how that works. So remember these replicas that we looked at earlier? Well, in the multi-zone case, we take those same replicas and we spread them across zones, so your data is still available, even in the rare case that one of the zones is lost. And we spread the storage class across multiple zones on a request-by-request basis. So when the request comes in, it goes through the same checksum bracketing as I described earlier, only the storage devices it uses are spread across zones. And by the time you get a 200 success response, your data is already able to tolerate the loss of an entire zone with no impact to the integrity of your data. So the same processes I just told you about apply, but now they're stretched across multiple availability zones. It turns out that this also has availability benefits. So let's say we have the temporary loss of an availability zone, for example, due to a power event. We're able to route around the failure and serve your data without you even knowing that there is an ongoing issue. So let's go over the key takeaways from the talk today. First, culture is key. So durability reviews are central to that culture of durability for us. And everything that we do starts with a durability review. Our team is relentlessly focused on the durability fundamentals. And 11 nines of durability, this goal is a central part of those fundamentals. This is something that we take very seriously. Our multi-availability zone storage classes add protection beyond 11 nines of durability to withstand availability zone failure. And our multi-availability zone durability also provides high availability. I want to thank you all for taking some time to learn about Amazon S3 durability and availability. Please make sure to stay tuned for some more awesome AWS Storage Day content, including a talk I'm really looking forward to on Amazon S3 security and access control. Thank you.